How's it going? This is the 5th video vlog of my vlog series, and today I interviewed one of my peers, Will Runyon. Will's been like a great friend to me throughout this process of being here at Mankato. He's a junior this year. He's from Omaha, Nebraska, so it's kind of cool that my first internship I was living down in Omaha, not too far from his place, somewhere around Nebraska City is where he's from. So it's like 30 minutes or something like that. So it was kind of cool. Saw him a few times over the summer, but like I said, he's been a great friend. He's also been there to help guide me through certain processes during school. Just going, asking him questions, kind of being a mentor for me. So given that Will hasn't been like in the industry for very long, he still has a massive amount of knowledge specifically in the concrete division of construction. So in his most recent internship, he worked with PCL, and PCL is a general contractor that's based in the Twin Cities, but they have a concrete division. So what he was working on was a new parking ramp on the Minneapolis airport. So like with that, there's a ton of problems that you can run into. Like you have airspace, you have a limited amount of laydown area because of like how many people are running around you, and also it's a site logistics like headache of how you get your how you get all your materials in there in like an orderly fashion without like blocking traffic. How do you get your cement trucks in and out? All these problems. Where can you put your cranes? Like it's just crazy because of the limited space that you had. So I went through and talked to him a little bit about site logistics, about his project and problems that he had. And then we also went a lot into concrete, what different types of concrete you can have, different reinforcement, and he's kind of like just a brainiac on concrete. So we started talking about your typical concrete. It's made out of, you got water, aggregate, and cement. That's basically your three main ingredients. So your water is just plain old H2O that you drink, and then the aggregate, you can have different types of aggregate. Aggregate is like different, like smaller rocks. It could be partial sand. It's usually slate or just tiny ground up rocks is what it is. You can have like big huge ones too, depending on what size of project you're doing. So it's really, it all depends on like what kind of concrete you want. It's mind-boggling to know how many different types of concrete you can have. And then you also have the cement. It's usually Portland cement is the most common type. The cement is like, when you look at a slab of concrete laying on the floor like a sidewalk, that's not cement, that's concrete. Cement is just the compound that hardens and cures over time. And then you can have certain additives in the concrete that make it cure, take it longer to cure, shorter to cure. If it's colder, you need to have a certain type of additive. They're called admixtures is what they are. And then so I think there's like 9 different types of admixtures, so we kind of ran through that. And then we started talking more about reinforcement. And on his project, he had something really cool. It's called fiber reinforcement, but we'll get into that just a little bit later. So with concrete, if you just pour it there and leave it, and say like it's a 4 to 5 inch slab, something like that, and you just pour it there, it's gonna crack over time. So you have to have some sort of reinforcement when the earth moves, and like, because you're gonna have, whenever the temperature warms up, it expands, and whenever it cools down, it contracts. So when it expands and contracts, it's gonna want to break somewhere. So what you actually have are relief cuts, where you actually cut the concrete, and then that's where you want it to break. So it's like kind of controlling it. So like say that, for example, say that this is my concrete slab here. If I cut right here, it's most likely gonna break right there. So then like you have controlled cracks of where it's gonna be and where it can flex and move. But the reinforcement is rebar most typically. Most typically it's rebar, and there's different types of sizes of rebar. They're usually about like a 1/4 to 3/8 inch thick. So 1/4 to 1/2 inch thick is usually what they are. And these are there just to make it more rigid and make sure that it can't like do any wave things or big buckles in the middle of the concrete. And then you also have welded wire mesh. That's more like fine. It's maybe like a 1/16 of an inch thick, but it's like a big fence is what it is that you lay down in the concrete, you roll it out, and then you have guys that come with some hooks and then pull it up while they're pouring cement on it, because you don't want it just laying on the bottom. You kind of want it up a little bit in the middle, so they'll go around with hooks and kind of pull it up a little bit. So that's welded wire mesh. And then what he added on his project, as well as all that, was fiber reinforced concrete. You can also have shredded steel reinforced concrete, but what fiber reinforced concrete is just a bunch of tiny strands of fiberglass that are mixed into the concrete. And what that is it's like a bunch of cross sections that like kind of try and hold the concrete together. It's kind of like thinking about like a textbook. I don't know if you've ever done this with a textbook or a phone book, but you like lap like every single page over and over and over, and then you try and pull it together at the end, and there's no way you can do it. Like, I've seen people take tanks to these things and do like steel binders on the ends of them and just pull it with tanks, and they won't move at all. It's just crazy to know like what friction does. So if you have a bunch of tiny strands mixed in this concrete, once it cures, it's not going to want to pull or move apart at all. So that was kind of cool to learn more about. And then you also have the steel reinforced, which is a little bit thicker. They can be used for a ton of different projects, ton of different uses. That's a bunch of engineering difficult crap that I'm not going to be paid enough to know about. So moving on to concrete. Within concrete, there is also like you have little bubbles. This is called air entrained admixture. So what that is basically they inject air into the concrete while it's being poured. So then there's like little tiny air bubbles, and you think, well, why would you want like air bubbles in your concrete? Is that going to make it weaker? But actually, what that is it's to help prevent concrete from cracking. So it's to help prevent cracking. And then so you think like, well, if you put a bunch of holes in it, it's going to be weaker so then it can break. But the answer is no. It's 'cause they're like microscopic, like not microscopic, really, really tiny bubbles of air in there. And concrete is really porous, so concrete takes in a ton of moisture all the time. And then so when it's taking on that moisture, and it hardens, when it gets smaller, it tends to crack. And then when it gets bigger, that's when it really breaks. That's the biggest problem with concrete, is when it warms up after the winter. That's when it breaks. It doesn't break when you're going into the frosting, where it actually starts to compress. So the reason for the bubbles is if you have all this moisture in the concrete, it wants to escape somewhere. It wants to get out. So if you have little bubbles within your concrete all over the place, and you have moisture that's in here, what the moisture is going to do is it's going to go into this bubble, and it's going to have a pocket to sit around in. So then when it warms up, it goes into here versus not having anywhere to go and just pops. So that it's kind of sciencey, kind of cool. Something that we talked about and learned about. Well, something that we talked about and I learned more about. But like I said, he's just a book full of knowledge. Learned a lot about concrete. Learned a little bit about the company and the project that he worked with too. Problems like that he was talking about, like the sounds like a World War II bomber. Sorry about that. But yeah, learned a lot about the site logistics that he was on with airspace, limited laydown, a couple of that. So laydown is where you just drop off materials that you're going to use to build the project. So say like they need to put down like 50 tons of steel reinforcing like rebar. And then so they need to figure out where can we put this. We also have to put our welded wire mesh down here. We also have to have a washout space for our concrete chucks, like just a ton of different things that they had to figure out where to put down. So yeah, thanks for listening, and I'll catch you next time.